question of how many equipment grounding conductors can be terminated at a single point is a crucial one for electrical safety and code compliance. The general rule is one equipment grounding conductor per termination point. This means each equipment grounding conductor should have its own dedicated screw, lug, or other approved termination method in the grounding bar. The reason for the single conductor rule is to ensure a reliable and low impedance path to ground for each equipment grounding conductor. If multiple conductors are crammed under a single termination, the connection may become loose or corroded over time, increasing the impedance of the ground fault path. A high impedance ground fault path can prevent overcurrent protective devices such as circuit breakers or fuses from operating quickly and effectively, potentially leading to equipment damage, fire hazards, and electrical shock hazards. There are exceptions to the one conductor per termination rule. These exceptions typically involve specific types of grounding and bonding arrangements, such as those found in industrial settings or with separately derived systems. However, these exceptions are clearly defined in the National Electrical Code, or NEC, and should only be implemented by qualified and knowledgeable individuals. It's important to always consult the latest edition of the NEC and any applicable local codes to ensure compliance with all grounding and bonding requirements. When installing equipment grounding conductors, be sure to use the correct size conductor for the circuit it is protecting, as specified in NEC Table 250.122. The equipment grounding conductor must be properly identified, typically with green insulation or green tape. The termination points for equipment grounding conductors must be clean and free of corrosion. Use appropriate tools and techniques to ensure a tight and secure connection. Never rely on wire stripping alone to make a connection. Always use a listed connector or termination device. In summary, adhere to the one equipment grounding conductor per termination point rule unless specific exceptions in the NEC apply. This practice ensures a safe and effective grounding system, protecting people and property from electrical hazards. Always consult with a qualified electrician if you have any questions or concerns about grounding and bonding requirements. Proper grounding and bonding are essential for electrical safety. Improper grounding can lead to dangerous situations, including electrical shock and fire. Make sure to always follow the NEC and local codes when working with electrical systems. The size of the equipment grounding conductor is determined by the size of the overcurrent protective device protecting the circuit. For example, if a circuit is protected by a 20 amp circuit breaker, the equipment grounding conductor must be at least 12 American wire gauge copper. If a circuit is protected by a 60 amp circuit breaker, the equipment grounding conductor must be at least 10 American wire gauge copper. Refer to NEC Table 250.122 for the specific requirements. The equipment grounding conductor must be connected to the grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode system provides a path for fault current to return to the source. The equipment grounding conductor must be installed in the same raceway or cable as the circuit conductors. This ensures that the impedance of the ground fault path is minimized. The equipment grounding conductor must be continuous and unbroken. It should not be spliced or cut. If a splice is necessary, it must be made using a listed connector. The equipment grounding conductor must be securely connected to the equipment enclosure. This ensures that the equipment enclosure is properly grounded. The equipment grounding conductor must be protected from physical damage. It should be installed in a raceway or cable that provides adequate protection. The equipment grounding conductor must be identified. It is typically identified with green insulation or green tape. The equipment grounding conductor must be accessible for inspection and testing. It should not be concealed or covered up. The equipment grounding conductor must be properly sized. The size of the equipment grounding conductor is determined by the size of the overcurrent protective device protecting the circuit. The equipment grounding conductor must be properly installed. It must be installed in accordance with the NEC and local codes. The equipment grounding conductor must be properly maintained. It should be inspected regularly to ensure that it is in good condition. Proper grounding is essential for electrical safety. Improper grounding can lead to dangerous situations, including electrical shock and fire. Make sure to always follow the NEC and local codes when working with electrical systems. The NEC provides specific requirements for grounding and bonding. These requirements are designed to ensure that electrical systems are safe and reliable. The NEC is updated every 3 years. It is important to stay up to date on the latest requirements. The NEC is available for purchase from the National Fire Protection Association, or NFPA. The NFPA also offers training courses on the NEC. Understanding the NEC is essential for anyone working with electrical systems. Proper grounding and bonding are critical for electrical safety. Always follow the NEC and local codes when working with electrical systems. If you have any questions about grounding and bonding, consult with a qualified electrician. They can help you ensure that your electrical system is safe and compliant. Grounding and bonding are complex topics. It is important to have a thorough understanding of the NEC requirements. There are many resources available to help you learn more about grounding and bonding. These resources include books, articles, and training courses. Take the time to learn about grounding and bonding. It could save your life. The equipment grounding conductor's purpose is to provide a low impedance path for fault current to return to the source, allowing the overcurrent protection device to quickly trip and clear the fault. This minimizes the risk of electrical shock and fire. The equipment grounding conductor connects non-current carrying metal parts of equipment to the system grounded conductor, the grounding electrode conductor, or both. This includes metal enclosures, motor frames, and other conductive parts that could become energized in the event of a fault. Grounding ensures that these parts are at or near ground potential, preventing dangerous voltage buildup. The grounding electrode system provides a connection to the earth, stabilizing the voltage to earth and providing a path for fault current to dissipate. It typically consists of a ground rod, metal water pipe, or concrete encased electrode. Bonding is the process of connecting together all metal parts that are likely to become energized, creating a common ground potential. This includes metal conduits, enclosures, and equipment frames. Bonding minimizes voltage differences between these parts, reducing the risk of electrical shock. Properly installed grounding and bonding systems are essential for electrical safety. They protect people and property from electrical hazard. Always follow the NEC and local codes when working with electrical systems. Understanding the principles of grounding and bonding is crucial for electrical professionals. It ensures that electrical systems are safe, reliable, and compliant with applicable codes and standards. Remember to consult the latest edition of the NEC and any applicable local codes to ensure compliance with all grounding and bonding requirements.